Good morning, Chemistry 222 cadets. I hope everybody is wonderful at your far corners of the world, wherever you might be this morning. It's sunny in Colorado. Just to recap where we're at, we're on lesson 25. It's 16 March. You need to get your results report for experiment 5, water hardness done by EDTA titration. That must be turned in by lesson 26. Oops, let me do that again. Lesson 26. Alrighty, so that's through email, an email attachment as PDF or Word document to both Captain Friday and I at our USOFA email accounts. And today we are going to talk about potentiometric methods. So this is chapter 14 in the black covered 8th edition Harris textbook. Anyhow, so this is an important group of electrochemical methods in which, as the name implies, we are going to be interested in measuring the potential of an apparatus, and Ohm's law tells us potential is current times resistance, okay? And the critical thing is whatever potential we're measuring is going to somehow be related to the concentration of some analyte species of interest. So we're going to use these devices to quantify very specific chemical species. So how do they work? What do we do here? So the overall cell potential that gets measured in these devices comes from multiple sources. We have a potential coming from our reference electrode. We have a potential coming from our working electrode where the reaction of interest is occurring. And we have another potential called a junction potential, which just is generated in the apparatus itself. Not to worry, it's a constant. So in the measurement of all those potentials, we want to consider the sources. So when we think about the components that are in a potentiometer, first of all, we have a reference electrode. The purpose of the reference electrode, component number 1, is just to generate a constant and known electrical potential. And we're going to compare other potentials to that one. The other component is the working electrode. The working electrode is there to sense the potential generated by some chemical process, a redox process. So we have some analyte species of interest undergoing a redox process of some kind, giving us product, and that reaction generates a potential, and that potential has some functionality to how much of the analyte is present. Other components, we always have to have a voltmeter to measure and compare the potentials that are generated in the cell. Oops, not the erase that. I want a potential there. Measure the electrical potentials in volts of the reference electrode, the working electrode, compare the two, record the two. All right, so in terms of apparatus, those are the primary components that we have in these measurement devices. And so the important thing to recognize in how we apply this to get information about an analyte. So expounding upon the equation written here, and focusing now on the potential measured at the working electrode. So we've got our analyte species of interest undergoing a redox process. Okay. some number of electrons involved, that's a reduction. And that's a process for which we can look up a standard reduction potential for that process. And the Nernst equation tells us that this potential at the working electrode is that measured under standard conditions, 0.0592 over number of moles of electrons exchanged as shown here. Log of Q, okay, Q is the reaction quotient for this reaction. So Q is going to be the concentration of B to the B over A to the A. So obviously the reaction quotient here depends on the concentration of our analyte of interest. As that varies, this potential is going to vary. And so this overall cell potential we measure will vary with the concentration of our analyte. Okay. The other contributing potentials to the overall cell potential up here are that coming from the reference electrode and the junction potential. And the most important thing to recognize about those, this is a constant for a given apparatus, and the reference electrode potential is a constant and known. So the only unknown and variable in the measurement of this cell potential is coming from the variable amount of our analyte of interest.